Hey guys, so these are some notes and examples for you to copy into your notebook. So we are going to be looking at objective or lesson 8.2, which is to multiply a monomial times a polynomial and to factor a monomial from a polynomial. So in our first problem, I'm going to show you two ways to think about these problems. Number one, so this will be, call this example number 0. So if I want to multiply a monomial times a polynomial, and in this case it's going to be times a binomial, I can think of this in two ways. So first of all is just as a distributive property problem, and I am going to want to multiply 2x times 3x and 2x times plus 1, and I can't leave out this plus. It has to come along for the ride so that I can separate my terms. So I'm going to write this out the long way. So I'm doing 2x times 3x plus 2x times 1. So now all that stuff we've been learning about how to multiply two expressions and using the exponent rules is what I'm going to use here. When I combine like terms, I just worry about the coefficients, but when I am actually multiplying, I have to use my exponent rules. So in this case, we're going to take our plain old numbers, 2 and 3, and they don't have powers, so we're going to use just the plain old rules of multiplication, and I can change the order. So I've got 2 times 3, and then I've got times x, and then plus 2x times 1. I hope you're okay if I don't break that down any further. That's just equal to itself. So now for my first term, I've got 2 times 3 is 6, and x times x. Remember, I've got two terms with the same bases. The power is that imaginary invisible 1. So now I'm going to keep my base, and 1 plus 1 is 2. And so that is how you multiply using the distributive property. So another way to think about this problem is to use something called the box method. And so if I've got a monomial, so that's going to be out here to the side, and I've got a binomial. So I need to create a 1 by 2 set of boxes, and I could put each term above the boxes. So this way I know that whatever goes in this section right here is the solution to whatever I get when I multiply these two terms. So 2x times 3x is 6x squared. 2x times plus 1 is plus 2x. And so I want you to remember this for when we are working some bigger problems on down the line. We'll use the box method to help us. So a 1 by 2, a monomial times a binomial, 1 times 2 is 2, you end up with 2 terms in your answer. So let's work some more problems and practice. In example 1, we want to multiply negative x cubed times a trinomial. So that's going to be times 9x to the 4th minus 2x cubed plus 7. And so for this one, for monomials, I don't need to draw out the box every time. So I'm going to use distributive property. And I'm going to write down everything that's getting multiplied. So in my first multiplication, I've got negative x cubed times 9x to the 4th. Then I have a minus sign. Minus negative x cubed 2x cubed, so that's the minus from my term. Then I've got a plus, so now I'm going to go negative x cubed times 7. So those are my multiplication problems for distributing this out. Negative times a positive is negative 9x, and then I've got a 3 plus 4, so I'm just going to write that out this time. And then negative x cubed times 2x cubed is going to be a negative times a negative is going to give me a positive. So 2 times 1 is just 2x. 3 plus 3 is going to be my exponent, and negative x cubed times 7 is going to be negative 7x cubed. So now let me go through and finish it off. I've got negative 9x to the 7th plus 2x to the 6th, and I can go minus 7x to the 3rd. In example 2, I am going to be doing the opposite. I'm going to be getting one of these expressions and searching it and seeing if there's some greatest common factor that can be factored out. Why do I want to do that? So this is in example 0 and 1. This is called expanding or multiplying. In example 2, so I want to know what is the GCF of 5x cubed plus 25x squared plus 45x. And so I really need for you guys to do a quick little review here on what does GCF mean. It stands for greatest common factor. So what it means is the, what's the biggest thing that goes into all three of those. So here's how I'm going to do that. I'm going to write my terms. Let me change my camera. I'm going to write my terms each individually. And this one is positive, so I need to keep that in mind. And I'm going to draw kind of an upside down division symbol. And I'm going to just look very carefully at each of these three terms and see what goes into all three of them. And so I can see pretty much right off the bat that 5 is going to go into all three of them. So I'm going to write my 5 out to the side, and I'm going to do this term divided by 5. So I end up with just plain old x cubed. 25 divided by 5 is 5. And 45 divided by 5 is 9. So then I'm inspecting my terms that I have left, and if I find something else that will go in, I draw another division bar, and I see that x goes into all of them, x to the first. So the lowest power of x is how many will go into all of them. So now I'm doing a division. I'm doing x cubed divided by x to the first. And I'm going to just write it out to the side here. I really hope that you'll get to where you can sort of complete that in your head and know that rule. This one divided by this one, the rule is you subtract the exponents, so you end up with x squared. And then right here we'll do 5x squared divided by x to the first, and we get 5 divided by 1 is 5. 5x to the 2 minus 1, or x to the first power. And then 9x, well, that's to the first power, and we want to divide that by x to the first power. So we're not going to have any x's in that answer. So now I have x squared plus 5x plus 9. And then what did I factor out of everything? A 5 and an x. So the way I'm going to write my final answer is that the monomial part of the answer is going to be the stuff that we factored out, and then the trinomial part of the answer is the stuff that was left over. So let's try another one of those. This would be a try it problem, so I'm going to work it out, but you can pause the video and see if you know what to do. So I want to know what is the GCF of three x to the fourth minus 9x squared minus 12x. So now you can pause the video and I'm going to work it out. So first thing I would do is to place all of my terms somewhere where I can show that I'm actually finding things that go into all of them and dividing by it. So I'm looking at the numbers 3, 9, and 12. So I think the biggest thing that goes into all of those is 3. And then if you notice from the last one, if all of the terms each have an x in it, the lowest power of x out of any of them, I'm predicting that it goes into all of them. So let's see what 3x to the fourth divided by 3x is. So if you're not to where you can do that in your head yet, you can write it out. And 3 over 3 is 1, x to the fourth over divided by x to the first, so we subtract, so we get x to the third is what we get after we divide that out. Then minus 9x squared, and I'm dividing that by 3x. So I do negative 9 divided by 3 is negative 3. X squared divided by x. I'm going to use the subtraction principle. So my final answer for that one is negative 3. 2 minus 1 is 1. And then negative 12x over 3x. And let me adjust my camera. Negative 12x over 3x is negative 4, and then x over x, so that's x to the 1 over x to the 1. 1 minus 1 is 0, so there's no x's left there. So now I've got minus 4. So I would just do a quick check of x cubed minus 3x minus 4 and see if is there anything that goes into all three of them. And there is not. So once you've found the GCF, so right here is our GCF. Once you've found the GCF, that's all this problem is asking for. But if we want to write it out as a factored or simplified expression, we take that GCF that we factored out, we say that GCF times this expression, that is factored form or simplified form. Okay, so we've already done a couple of these problems, but we are gonna, this is probably one of the more challenging things we've done so far. We are gonna write out the factored form of a monomial. So this is example 4, and so the way this question would be answered, what is the factored form of, and then let's see, let me zoom up a little bit. What is the factored form of 4x to the 5th minus 24x cubed plus 8x? And so if I can, I'm going to draw my division symbol right underneath. So see, I wrote it somewhere where there was room where I could show my division symbol right under there. And I'm looking for something that goes into all three of these. So if you're confused or if you're having a hard time with knowing what goes into everything, I'm going to show you the prime factorization of each of these. So that just means break that monomial down into prime factors. So 4 is 2 times 2, and then x to the 5th is x times x times x times x times x. So that is the prime factored form of that monomial. Then let's take a look at the others. Negative 24 x cubed. So getting any negative, first of all, the first prime factor is -1. So then I'm going to take a look at the factor tree of 24, and I'm just going to break it out any old way that I can. So 4 times 6, then keep breaking those down until I can't divide anymore. So here I've got the factored form, which is 2, 2, 2, and 3. And the last one, oh, I forgot my x cubed, so there's going to be 3 x's. Then 8x factored form will let me go ahead and do a factor tree on that. So the prime factorization of 8 is just 2 times 2 times 2, and then there's 1x. So another way of finding the GCF is to take a look at the prime factors and circle anything that they all have in common. So starting with a 2, they all have a 2, they have 1 2, and now here I've got another 2 that is in all 3 of them. And then here I've got another 2, a 3, down here's a 2, but I'm all out of 2's up here. So for the number part, 2 2's is going to be it. Now looking at my x's, down here I see, well, the lowest power is 1. So they all do have x to the first power as part of the GCF. So, and there's no more x's here. So to know what the GCF is, the greatest thing that goes into all 3 of them, I can just multiply these 3 things that I have circled. And so now I've got my GCF. And that's what I'm going to divide out of each term. So 4x to the 5th divided by 4x. Let me come down here and show my division. So 4 divided by 4 is 1. X to the 5th divided by x to the 1st. I would do my subtraction. So my final answer for that is x to the 4th. And if you look, when I prime factored 4x to the 5th, you'll notice that this x to the 4th, that was what was left here after my GCF had been circled. So let me do the same thing by dividing -24x cubed by 4x.